sequence. So I have an example on how to show that a sequence is a converging sequence. And here is the example. Suppose you are given a sequence xn equals to n squared, and you are being asked to show that this sequence is converging at a point. So from definition of a converging sequence, from definition we say that a sequence is converging if given epsilon greater than 0 and a natural number, say n, also greater than 0, such that the absolute of that sequence xn minus a point a. This point a is where that sequence is converging, should be less than epsilon for all n more than or less than natural number, say n. Then thus the limit of that sequence as this n is tending to infinity must exist. So that's the limit of that sequence must exist. So we needed to show that this sequence n squared actually converges at a point. So we have our sequence xn equals to n squared. We need to show that this sequence is a converging sequence. First, we must get the limit of this sequence. And as you know, if the sequence has a limit, then that sequence is a converging sequence. But if a sequence has no limit point, then that sequence is a diverging sequence. Now let's see if we can get the limit of this sequence here. So limit as n is tending to infinity of n squared. So n is tending to infinity, and this n is a natural number. Therefore, n is 1, 2, 3, up to infinity. So if I have 1 squared, 2 squared, 3 squared, these are just natural numbers, 1, 4, 9. So they will contain like that up to infinity. Therefore, the limit as n is tending to infinity of n squared is equals to at infinity. What does this mean? It therefore means that this sequence has no limit. And therefore, as I've just said, that if a sequence has no limit, it means that that sequence is not converging. So sequence xn equaling to n squared is not a converging sequence because it has no limit point.